choose a pen. So we're looking at exercise 3.1. Exercise 3.1. And we're looking at number 33 in our textbook. Number 33. Okay. So they give us the following curve. Y is equal to 2x to the power of 3 minus x squared plus 2. And the point they give us is the point 1, 3. So we have to find the tangent line to this particular curve at this point. Okay. So now, that means we have to find the equation of this line. Obviously, we have to find the equation of the tangent line to this curve at this point. So we know that the tangent line is a straight line. So the equation has this form. Y is equal to mx plus c. So this is the form that the equation of this tangent line takes. It takes this form because it's a straight line, right? So we have to find the m first. So let's call it mt because we're dealing with a tangent, right? So we have to find mt, which is the gradient of this tangent. And to find mt, we have to differentiate our given curve. We have to differentiate y with respect to the independent variable, which is x. So mt is equal to the dy dx. So we have to differentiate the equation of the given curve, which is, of course, y is equal to 2x cubed minus x squared plus 2. So we go ahead and we differentiate that. Okay. All right, we'll go to the next page. This is my previous page. So now we're finding mt, we're differentiating y with respect to x. Let's go to the next page. Let's go ahead and differentiate y. So this is basically the following. So dy dx is equal to the derivative with respect to x of 2x cubed minus x squared plus 2. So that's what we're differentiating. So we go ahead and differentiate the first term, and we get 2 multiplied by 3, which is, of course, 6. So that's going to be 6. Okay, let me go back there. Let's write that properly. Okay, so this is 6. It's 6x squared. That's the derivative of this term right here. 6x squared. And the second term we get minus 2x. That's our second term. The third term, obviously, the derivative of the third term is 0. So if you differentiate 2, you get 0. So dy dx is equal to 6x squared minus 2x. Okay. Now, this implies the following. It implies that mt, which is our gradient, is equal to this derivative, which is dy dx. And now we have to evaluate this derivative, obviously, at x is equal to our point, our given point. Let's look at our given point. Our given point is 1, 3. It's the point 1, 3. So this is our given point, 1, 3. And we have to then evaluate our derivative here at x is at the x coordinate of that point, which is 1. So evaluate it at x is equal to 1. Okay. So now what that means is it means the following. It means that this implies that mt, okay, mt is equal to our derivative, and our derivative we saw it's 6x squared minus 2x. So we get 6x squared minus 2x. We evaluate this at x is equal to 1, which is the x coordinate of our given point. So we go ahead and substitute. So let's substitute this. We go 6. We put 1 in the place of x. We get a 1 squared there. And then we get minus 2. Replace the x with a 1 over there. So now we got 6 multiplied by 1, which is 6, minus 2 times by times 1. So that's basically 6 minus 2, and 6 minus 2, obviously we know is 4. So this is basically our MT. This is the gradient of the tangent line that we are looking for. So we go to the next page and we continue. So we say, therefore, we have the gradient now, which is MT is equal to 4. This means that y is equal to 4x plus c. So this is now our equation for the tangent line, but we're still missing the c. We still have to find c. Now, in order to find c, we use the whole, or we use both components of the given point, and the given point is 1, 3. So we use both components. So we're going to use the point 1, 3 to solve for c. So this implies that if we substitute in place of y, we put the y coordinate of our point, which is 3, is equal to 4. And in place of x, we put the x component, the x coordinate of our point, which is 1. Now we get that, and we go plus c. So now we go ahead and we work this out. So 4 times 1 obviously is 4. Subtract both sides by 4, and we get minus 4 on this side. And on this side, we get, obviously, we're going to get 4 minus 4, which is 0. And we have c. So this is basically implies that c is equal to, because 3 minus 4 is negative 1, so c is minus 1. So that basically completes our calculation. We now write the answer, which is the full equation for the tangent line. So the answer is y is equal to 4x minus 1. So 4x minus 1, this is the equation of the tangent line to the given curve at the given point. Thank you.